So here is another example where sum of roots alpha and beta is root 2 and product of roots alpha beta or alpha into beta is 1 by 3. So this is the standard formula to put the values in. K, where k is any integer constant, it can also be a real constant, open bracket x square plus b upon ax plus c upon a. We know these constants very well. These constants come from ax square plus bx plus c, which is the standard form of a quadratic expression. So standard form of quadratic expression obtained from the relation between sum and products of roots with the coefficients of the quadratic equation. So here we have b by a is minus root 2. How do you get that? Because sum of roots alpha plus beta is root 2, which is nothing but minus b by a. But we want plus b by a here. We don't want minus b by a. If minus b by a is root 2, then just b by a should be the opposite sign here. Let's send the negative sign here. So it will become minus root 2. So in place of b by a, we are not going to put root 2. We are going to put minus root 2. And now c by a, as such we know alpha beta, the product of roots is nothing but c by a. In this case it is given as 1 by 3. So we won't make any changes to it and we will directly substitute. In place of c by a, we will substitute 1 by 3. And we know very well alpha and beta are the solutions or zeros or roots of the quadratic equation. So let us substitute in place of b by a minus root 2. So we put here minus root 2. In place of c by a, let us put 1 by 3 and we have put it here where k is any real constant. Now technically let us put the value of k as 3. And now when we put, why have we taken 3? Because 3 is the denominator. So let us get a quadratic expression without the denominator. So when we multiply 3 with x square, we get 3x square. 3 with minus root 2, we get minus 3 root 2. Please do not multiply this because this is not under the root. This is under the root and you cannot multiply them as such under the root. So you have minus 3 separately, after that root 2 x, and then 3 gets multiplied with 1 by 3, which is nothing but 3 and 3 gets cancelled and you get 1. And now we can give another example as k as 6. So we have taken the double the value. So 6x square minus 6 root 2x, and when 6 gets multiplied here, 3 1s are 3, 3 2s are 6. So you get the constant as 2. So any one example is sufficient. Technically this is sufficient, but you know, substituting k with a constant value, suitable constant value, adds to the solution. Thank you.